Maurice, and thanks Atlas Camp for coming along to hear all about Forge Remote. All right, so let's start with the basics. Tim gave us a pretty good explanation yesterday around what we're up to with Forge Remote. But the simple way that I like to think about it is we're just trying to make it simpler and more secure to connect your remote backends with your Forge apps. It's nothing totally new. You've been able to connect or integrate with remote backends for Forge apps for almost as long as Forge has existed. But until now, it's been a pretty choose your own adventure when it came to. All right, so let's start with the basics. Tim gave us a pretty good explanation yesterday around what we're up to with Forge Remote. But the simple way that I like to think about it is we're just trying to make it simpler and more secure to connect your remote backends with your Forge apps. It's nothing totally new. You've been able to connect or integrate with remote backends for Forge apps for almost as long as Forge has existed. But until now, it's been a pretty choose your own adventure when it came to securing those connections. And you might ask, why Forge Remote? That is a fair question. And as Tim said yesterday, are we just trying to rebuild Connect on Forge? That is a fair thing to sort of wonder because, one of the great value props of Forge is that it's secure, it's trusted, and it does give you the ability to build apps that don't egress data and everything stays in the Atlassian cloud. So Forge is secure, but what exactly do we mean by that? I think a better way to put it perhaps is that Forge is secure by default. And to explain what I mean, I'm going to go on a little side journey. So this is your app fortress. This is where your app runs and hosts customer data. It doesn't matter if it's built on Connect or Forge. Any app is a fortress because it contains lots of valuable data. There's also lots of enemies out there on the internet who are trying to get into your fortress and steal your data. The good news is that if you build with Forge, it comes with this big wall for free. As soon as you run Forge Create, your fortress looks a bit like this. A really strong barrier against any unwanted trust problems that might come your way. There are some secure tunnels that will let you talk to the Atlassian products, but by default, nothing else goes in and out of this super strong wall. And we build a lot of clever defenses into the wall. There's egress enforcement, cross-site scripting protection, rate limiting, tenant isolation, lots and lots of things. And that's our mission with Forge, to not only maintain this wall, but we want to make it even stronger over time. We're continually adding new features and new protections that keep your fortress safe from any threats that might emerge. We're committed to building this kind of platform of trust so that your apps can inherit good security by default. Data egress is controlled and, by default disabled. So where does Forge Remote fit into this idea of a platform of trust? What about the apps that need to egress data by necessity? They may integrate with other apps that aren't on the Atlassian platform. They might be incrementally migrating over from Connect. They might be integrating with AI tools or LLMs, or perhaps they just need a little bit more than the Forge backend can currently provide for them. So of course, you can poke a hole in the wall. You do this by declaring egress permissions in your manifest. You can think of it kind of like a guard station, or we call it a trust control. And so we make sure that data is only going to those specified domains that you put in your manifest and have been transparently shared with the admin when they're installing your app. The problem though is that up until now, you've had to bring your own padlock and key when you're poking that hole in the wall. And, if we're serious about building this platform of trust with Forge, we know that we should provide the locks and keys, and all you have to do is adopt them. So yes, you may have the situation where you need to poke holes in your wall, but they still exist alongside a much broader defense strategy. A hole in the wall does not necessarily mean that the entire wall gets compromised and pulled down. It just means that the app is using the least amount of privilege it needs to get the job done that it's trying to do. And that idea of least privilege is something we're baking into Forge Remote, and we'll sort of come back to that as we dive into what we're building. Now contrast that with a Connect app. When you first create a Connect app, it looks more like this. The wall doesn't come by default. You're completely on your own when it comes to protecting your fortress. And as a result, as a developer, you need to build up that wall piece by piece. And there's plenty of developers out there, many of you are in this room, who are really good at building walls, but that doesn't change the fact that security is hard, and we'd really like to do more to sort of help you get more from the platform. Because with Forge, you start with this really secure fortress out of the box, and then you can intentionally and incrementally opt out of the security controls that we provide. Whereas Connect, you start with the blank slate and you build your controls up. Nothing comes for free from the platform. So with Forge, you may add feature by feature the things that you need to make sure you have that right level of trust and security. So where are we now actually with our Forge Remote journey? It all started back at App Week in Berlin back in February. Sajal and I ran a workshop in a room much smaller than this one to sort of share our loosely held ideas for what we thought Forge Remote might be. And we got some really great feedback out of that session, out of that App Week. We sort of took that home with us, published RFC 8 back in April. Tim already stole my joke for the keynote about the hard eyes, so we'll move on from them. But it was really well received. Again, more feedback, so we knew we were on the right track. We launched the EAP in June, which at first only included the ability to swap out a hosted resolver with a remote endpoint. But then quickly after that, we added remote events and the ability to access storage remotely as well. And then last week, we took all those features to preview, so now you can use them in your production apps. So diving into exactly what we built, let's start first with your typical native Forge app. You have your front end on custom UI or UI kit 2. You have a Forge function, you have Forge storage, and then you can communicate with the products via the APIs or getting events pushed into your Forge function. Now, when you add your remote into the picture, you can call it directly from the front end. So you can swap out that resolver for your front end with a remote. When you do that, we'll also, if you opt into it, give you some bearer tokens so you can call directly from your remote into the product APIs. You can also subscribe to product events to get delivered directly to your remote. And then you can also call from your remote into Forge storage. So if you need to do some compute remotely, but you don't want to store that data at rest, you can store it in Forge storage. Diving in again to the next level down, let's get into that front end to remote flow. Let's say we have a customer. That customer is looking at a Confluence page and it's got a Forge macro on that page. Now the Forge macro can invoke your remote backend. When we do that, when we send you that request, we're going to put an authorization header on it. And in that authorization header, there's going to be a Forge invocation token. And that's assigned JWT. And what you'll need to do is check the signature of that using the public key we have on the JWKS endpoint, or Jukes as Tim calls it. That lets you verify that it's from Atlassian and it's intended for your app. Then, if you've opted in to get the as user or the as app access token, you can call into the product APIs, and then you can respond, your app will re-render and go on its merry way. To adopt this, there's a small change, relatively small change to your manifest. So, should I try and use the pointer? Here, where you set your resolver, you usually put a Forge function, but now you can put an endpoint, and the endpoint will point to your remote backend, and also whether or not you're opting in to receive the access tokens as well. And this is what the front end experience looks like. So there's a new package on the Forge bridge called invoke remote, and it works very similarly to a JavaScript fetch function. This was one of the big changes post the feedback from the EAP. So shout out to everyone who was in the EAP. Thank you. But yeah, you can set the method you want to use. You can add some more custom headers if you like. You can set the path, the body, query parameters, whatever you need to send through to your backend. And on the backend side of things, we're going to add some default headers to the request. So as I said, you're going to get that authorization header. That's going to have the Forge invocation token in it. You'll also have the as app and the as user bearer tokens for calling back into the API. And we're also going to put some trace IDs on there, which is going to be really useful for observability and troubleshooting. Drilling into the invocation token itself, it's not just used for the authorization. There's lots of important data in there that your app's going to need, your remote backend's going to need. So you've got data about your app, so the version, the environment, things like that. We've introduced something called an installation ID, which is unique to this installation of your app. So if you're keying data that you're storing externally, this is the identifier that you'd be using. You get the API base URL if you're calling back into the APIs. You also get the app context, which if you've built a Forge app before, you'll be familiar with. And you get the principal, which is the user ID, and Pat might run through a few more of these fields in the demo. Switching over to the event side of things, it's quite similar, but also a little bit different. In this flow, you've got your customer, and rather than interacting with your Forge app directly, let's say they're leaving a comment on the Confluence page. That means Confluence is going to publish that created comment event, which will send to your Forge app, but it's actually going to go out to your remote backend. You're going to do the same thing. You're going to check the authorization header, get the invocation token, check it against the public key. Then we're going to request that you put it on a queue to process it asynchronously, because we've actually got a shorter timeout. It's only 5 seconds on the event responses, just because of the nature of product event traffic. So acknowledge that with a successful, like a 200 response or 201. Then you can process your event, and you can also call back into the APIs with the as app access token. And in this scenario, we've swapped out the function with the endpoint. The endpoint is similar, except here there's an extra part where you have to declare the path that you want us to route the event to, because there's no client-side code in the middle for you to change it dynamically in the case of product events. Around retries, as I said, we want you to respond within 5 seconds, otherwise we'll consider it a timeout. We want you to respond with a 2xx status code. If you don't, we'll consider it a failure, and we'll try and retry the send. It's going to happen 4 times with 60-second delay between each one. Cool. All right, that's enough looking at slides. I'll pass over to Pat, whose microphone's falling off.
All right, thanks Adam. Cool, so now we have a bit more context about what the Forge remote capabilities are. Let's jump into a demo and see how easy it is to add them to your Forge app. Cool, so before we jump in and start looking at the code, let's take a look at what a local development loop might look like for remote capabilities. So in this case, on the left-hand side, we have the Forge platform, and on the right-hand side, we have the local dev environment. We'll be running a couple of different processes. The first one being the remote compute server, which will expose out a bunch of REST APIs for the platform to invoke. And the second one being the custom UI React server, which is where we'll get the live reload loop for the UI side of things. Now, to tie this all together, we will have 2 tunnels that we'll also need to run, the standard Forge tunnel that you can run through the CLI for the front end, and a new tunnel for the back end to expose out those remote REST API endpoints out to the world at a well-known HTTPS URL. And you can use any sort of tunneling software to do this, so ngrok or Cloudflare or something like that. Cool, so with that in mind, let's build our Hello World Forge remote app. Okay, here you can see my beautiful styled UI for custom UI app. In this case, we've got a few components as part of this app. We have a label here, which is where we'll display our greeting. we have a get button and an update button. The get button will go and fetch the greeting from the remote server, and the update will go and update that remote greeting. Under the divider, we also have another component to display trace information about the requests flowing backwards and forwards between the front end and the back end. Cool, so with that in mind, we'll bring up the manifest, and we can see, as Adam talked about before, here it's very similar. We just have a macro. We're replacing the function pointer in the resolver with an endpoint pointer, and that endpoint pointer, Atlas Remote UI, will define a few things. Firstly, the remote tunnel that we're talking off to, which is the local tunnel, and the auth configuration. So we're opting in for both the user token and the system token to be provided to our backend. Okay, and you can see down here that remote is defined as that well-known URL. And we're also setting those permissions that we'll need in order to opt in to getting those two tokens. So that's that app user token and app system token, and this will display to admins when they install on your apps. Cool, so if we look now at the front-end UI code, and we can kind of see when you click those buttons, what's happening behind the scenes. We're making some fetch-based requests to our APIs, and on the onClick function handler, we're calling that invoke remote method to send that request off to your remote server. So if we now switch back to our UI side of things and see what happens when we click that button to try and make a request. Cool, so the request's been sent, we've got a 404 back because we haven't yet implemented the back end. So we switch over here, we've got a Java Spring Boot REST application, nothing Atlassian specific, nothing Forge specific yet. We're going to build a specific get endpoint, which is just going to echo back hello world greeting. And then it'll just say hello Atlassian. So let's fire that up and see if it works. Cool, so now if we go and fetch that, cool, we've got a greeting back, great. Or is it great? Ultimately, we've been able to now go and fetch a request from our remote backend, but if we come and curl this from out on the public internet, as our enemies might do, we can access that from an insecure context as well. So this is where historically, before Forge Remote, you would have to choose your own adventure in terms of what security mechanism, what padlock you're going to provide. Do you use some sort of shared security model, shared secret-based model, or sign your own tokens, those sorts of things? But really what that meant is you had to solve that for yourself, and we want to offload that to the platform. So if we now look at what a secure Hello World Forge Remote API might look like, we'll effectively change that existing implementation and try and lock it down with a more secure padlock. So in this case, what we're going to do is we're going to inject the Forge invocation token validator, and we're going to map onto that authorization header that's been sent through, which is the bearer token, and we're going to validate that. If that token's not provided, we're going to return a 401. And in the case that it is, we'll also perform some validation of that token that we'll get to in a second. So there's the 401, where it's not provided. And the validation side of things, there's some key things we need to validate here. So first one is that that key was signed with a public key that is within that JSON web key set, and that the expected audience maps to our app ID, so we can avoid any replay attacks, and that the issuer is coming from Forge invocation token. This is super important and part of the shared responsibility model to implement. And if we go and have a look at that JSON web key set, what effectively is that? It's basically just a big JSON blob of key IDs to public keys. And this is all kind of standards-based stuff, nothing Atlassian specific. So if we fire that up now, and we see if we can compromise that from an insecure context. Cool, so now we've locked that down. We can't get access from where we don't want to get access from, but can we access that from our Forge front end? Because that's obviously pretty important as well. Okay, so something's gone wrong here. So what is that? If we're going to have a look at the logs to see what it's complaining about. Ultimately, I think here there is an issue with the audience ID, where it should be matching to our app ID, which is something that's changed from the EAP. For those who are involved in the EAP, we're now using the full app ID ARI value, and we're copying that out and reconfiguring our backend. Running that up. And now hopefully we can make a security request from Forge. Great, so now we've used our padlock and we've been able to send requests backwards and forwards. So it's not only obviously GET requests, you can use any sort of HTTP methods, REST APIs, that sort of thing. You have the ability to provide custom requests and response headers, query strings, those sorts of things. So if we quickly implement the update function here for our UI, just to show some state flowing backwards and forwards for our Forge app. Cool, so very similar to our GET, just setting it a body, pulling out some state and storing that on the remote. Obviously you wouldn't do this in a real production app. And we change the greeting to a local greeting. Cool, so now we've been able to fetch that request backwards and forwards. So, what happens when things go wrong? Obviously it's software development, things always go wrong. So how can we investigate issues when we've now added some complexity with multiple components between the platform and the remote? So this is what the tracing headers are meant to solve. So in this case, what we're going to do is we're going to simulate an error on our remote server. So we're going to change that greeting API again. And in this case, we are going to throw an internal server error. But we're also going to inject this trace header that's being sent from Forge. And we're going to echo that back to the remote server as well. And say something bad happened. So if we fire that one up. Hopefully we should get a nice error message when we invoke that. Yep, something bad happened, 500 error. You can handle all of this within your front end code. We'll get this nice trace ID as well. So what can we do with that? Now if we switch over into the developer console, we can go and have a look at the logs for our development app. Take a look at the most recent logs, and we should be able to correlate the logs from the remote server with the platform. And we also have metrics available for all of your remote functions in the same way as we do for the hosted. You have the same invocation metrics, errors, all those sorts of things. And obviously alerts work as well. Cool. So now we've seen how you can build a very basic working app. But we've got a bit of an issue here in that we are now storing state on our remote server, which means we need to take on all of the burdens of compliance, data residency, all of those sorts of things, which might be a trade-off that you want to do for your app if you're doing some interesting process, some value add to that data. But for us, obviously we're not. It's pretty standard. We just want to store some data. So this is where Forge remote access to hosted storage could be helpful for your use case. So what does that look like? Let's change that implementation again. This time we're going to start storing that state into the hosted storage side of things. So for this, what we'll do is we'll inject a new Forge storage GraphQL client, so we can make requests off to storage. We'll get that bearer token that we provided and we opted in for, and we'll use that to authenticate with the storage APIs. We'll go and fetch that greeting from there, and we will display that back. We also need to get some information out of the Forge invocation token to build the storage partition ID, and we're looking to improve upon this in the future. So obviously update side of things, very similar, except we will be calling the set API. Alright, if we fire this one up, hopefully we have a similar working implementation. Go and get a greeting back. We can update that again to a different greeting, update that, and hopefully fetch that back as well. Now, if we switch over to the developer console, you can look at the new storage viewer. side of things, and we can see now that data is being stored in hosted storage, so no compliance requirements on you. Excellent. So we've looked at UI-driven invocations. What about remote event processing that we talked about? As Adam mentioned, very similar case to the user-driven interactions, except in this case, obviously with that large amount of processing, there can be a heavy load of events. So yeah, we really want to emphasize that asynchronous processing side of things. So you're getting a request from the platform, validating that Forge invocation token, which is super important, queuing that event, acknowledging back to the platform, and then processing that asynchronously. Obviously, you can use any sort of asynchronous processing that makes sense to you, but yeah, super important to do that. So what does that look like? Here we have the manifest, hosted trigger, very similar, except we're going to remove that function pointer and use an endpoint pointer instead. And we're going to opt in for listening to Confluence page created events, and we'll get those sent off to our remote endpoint. The remote endpoint here, pointing to the local tunnel again. The path is static to /events, and this will always be a post. And again, we're opting in for the app system token because there is no user access token in a UI, because this is not a UI driven flow, it's a backend flow. Excellent. Now if we look at implementing the backend for this, very similar. We're going to inject an event queue here. This is an arbitrary pretend event queue. But we're implementing the post /events. Very similar API pattern. We have the Forge invocation token we need to validate, our system token that we can use in future, and then a big blob of JSON effectively, which is the event data that we're receiving, and that'll be different for each event type. Yeah, when we get that event off, we're going to build the data object, add that to the queue, and then acknowledge that back to the platform. So if we fire this one up and give it a test, what we should see when we come and create a new Confluence page is that event should be sent off to our remote server. We validate that Forge invocation token, queue that event, acknowledge it back, and then do some logging effectively because we haven't implemented the event listener yet. Cool, so we published that page off. Excellent. And hopefully in there we can see the logs, maybe not, it's been zoomed in. Alright, anyway, we've received a event and we've logged that out, but let's go and switch that across to implement something a bit more interesting when we get that event. So in this case, this is the event loop, not doing really anything interesting, just calling this function to handle the event. What we're going to do now here is we're going to use the OAuth token that was provided, and we're going to grab some data out of the JSON event to go and create a comment on that page. So we can have the page ID, page title, and the API base URL from the Forge invocation token. Use that to make a REST request to Confluence to say, hello Atlassian, the page title is whatever the page title is. Cool. So if we now fire that one up, and we create another page, hopefully what we should see is that once that event has been queued and processed, we should also see a page comment be created, though again I think if it's zoomed in we may not see it. Hopefully we can. Maybe not. No, we did. Okay, excellent. So yeah, if you run into any issues, if you return a 5xx response from your API, then as Adam mentioned, we're going to retry those events up to 4 times with the 60-second delay in between. Cool, so with that in mind, I'll hand over to Adam to talk through what's coming up next with Forge Remote.
Awesome. Thank you, Pat. I was still feeling nervous for you, even though it was a canned demo, so well done. It was very authentic. Yeah, so obviously we're pretty pleased with what we've managed to get through into preview so far. We reckon that's going to unlock a whole bunch of use cases, but we're also obviously not done yet either. So there's a bunch more stuff we need to keep building as we go into next year. The first one is support for multi-regions. So even though the remote invocations don't use a Forge Lambda, they still go via our Forge invocation services. That's so we can add those headers in for auth and things like that. And currently, they all run out of US West 2 in Oregon. But fortunately, as Tim mentioned yesterday, sort of in preparation for data residency for Forge, we're already making those services multi-region in all the regions that Atlassian supports. And so sort of when that's done, either later this month or early next year, we'll be able to offer that multi-region compute support for Forge Remote as well. So you'll be able to go into your manifest and specify all the different base URLs for the region that your app supports as well. Next one, offline access. This was called Milestone 3 for those of you who remember the RFC. We know there are going to be use cases where you're going to need to still have access to Atlassian APIs, even though there hasn't been a UI invocation or there hasn't been a product event. You may have things coming in from other apps and systems. You may have scheduled triggers, things like that. So this is still something we're keen to provide and to solve for. Not sure exactly how it's going to work yet, but keep your eyes out for another RFC, I'm sure. We also want to provide the ability to go directly from a Forge function to a remote. So you might want to do some of your compute on Forge and some of it remotely. You could use a Forge function as kind of like a webhook trigger, webhook filter, or something like that. So yeah, that's something we're keen to build as well. It'll probably look something similar to how it looks in the front end with the Invoke remote. And then finally, going back the other way, having the ability to call from your remote into a Forge function. You can obviously do that at the moment using web triggers, but they are entirely open. So again, that choose your own adventure auth experience. So we know we can definitely do better there. We also might look at fixing up some of the other pain points for web triggers and being able to have one with a knowable URL and things like that. So it may even be a different module, I'm not sure yet, but that flow in general is something we're keen to improve on. So sort of to bring it all together, we're really excited about Forge Remote. We think it's really going to sort of improve what's possible on Forge and really expand what's possible. We are trying to focus on making it as simple as we can. And by simple, I mean adopting as many standards as we can and staying as true to that, like OAuth and things like that, minimizing the Atlassian secret source. We want to extend the trust of Forge as much as we can, things like the access tokens being tenant isolated, so that extends out now to your remote as well. Whatever we can do to sort of cleverly design for that, something we'll continue to do. And of course, we want Forge Remote to be flexible. We basically want any use case to be able to run on Forge, and so we need to finish out that roadmap of features as well. And just one last thing before I finish. I'm sure there's plenty of you out there thinking all this Forge Remote stuff sounds great, but my app is running on Connect and I don't know how I'm going to get to Forge. Well, fortunately, we have these three fine gentlemen here in Copenhagen this week, and they are very keen to talk to anyone who's thinking about migrating to Forge. The team's done a lot of work on that sort of migration experience and Connect on Forge. So if you haven't had a look at it for a while, I encourage you to do so. We've added support for Forge Remote to ACE for the JavaScript framework for Connect. Support for Spring Boot is coming really soon, and they've also got like some example apps and things they can walk you through. So if you're lucky enough to be here for the rest of the week, definitely try and hunt them down. Otherwise, maybe hunt them down at drinks this afternoon. and have a chat.